When I was asked by Teachers TV to present a masterclass in maths, I chose to teach a lesson about equations. My students are Year 9s from 2 North London schools. Let's go. Take your T-shirt off. Put your T-shirt on. We've got T-shirts on today. Some of you have got numbers on. Some of you have got... Oh, stand up, Mitchell. What's that?
It's a plus.
A plus sign, an operating sign. You've got an X on. Oh, it looks a curly X. A curly X. And you've got, you've got a straight X. Do you think that's a times? Yeah. Could be easily confused. What do you think this curly X is then?
A variable.
A variable. All these letters are variables. What does variable mean? It could be anything. Shout it.
Could be anything.
Very important. It could be anything. We don't know. Can we have the person who's wearing 2? That's Kishan. Okay. Up you come. 2. We'll have you times 2 times T, I think. Yeah. Up you come. 2 times T. Okay. What have we got now then? 2 times T. What's the answer to 2 times T?
2T.
2T. What do you mean 2T? What's happened to the times?
Not needed.
It's not needed because it looks a bit like Ben's, doesn't it? Stand up, Ben. It looks like that curly X, doesn't it? So we don't want to get confused. In fact, you can sit down, Rohan. 2T means 2 times T. This is an expression. Okay, so what's the answer to 2T?
2T.
2T. Because there's no answer, is there? Okay, 2 times T. But if I said T was 12, what would the answer to 2T be then?
24.
The value of 2T would be 24. Excellent. Okay. Plus, up you come. Let's have some fun. 2T plus 3, I think. Yeah, up you come. I knew you were itching to come up. Okay, what have we got now? 2T plus 3. Is this an expression?
Yes. Yeah.
Okay, how many terms has this expression got?
2.
2 terms, okay. What are the terms then?
2T and 3.
Okay, 2T and 3. Brilliant, okay. Can we simplify that anymore? No. Okay. Now then. Do you like that?
Yeah.
Equal sign. Okay, I want another number first. 11. Can you come up? Right, Samuel's 11. What have we got now?
Equation.
Why is it an equation?
Because it's got an equal sign.
It's an equal sign. It's an equal sign. Okay, so we've got an equation. Who can solve the equation? T equals 4. Let's just check that one then, okay? So, we've got 2 times 4, that's 8, plus 3 equals 11. Hey, I like this. I tell you what, can you sit down? Can we have a 5 up here? See if it still works. You're very good. Okay, 2T plus 5 equals 11. What's the value of T now?
T equals 3.
Brilliant. I'm really happy with that. Thanks a lot, guys. Sit down, please. Brilliant. Fantastic. Give them a round of applause. Absolutely. Okay. Now then, welcome to my Equality Street. I thought you'd be impressed. I've opened up this new shop. As you can see, it's got a range of things on it. We've got these lovely oranges. Look at these. Who fancies an orange? Woohoo! That's a round of applause, isn't it? Yeah. Have an orange. Have an orange. Okay, but most important of all, we've got some chocolate. Brilliant. Excellent. Now then. The people who are wearing yellow T-shirts, did you feel a bit left out? You weren't getting very involved, were you? Come on, give them a round of applause. Right then. Okay, Agni, could you stand right next to me? Right up to next to me. Brilliant. So, Agni, you are very, very generous because, do you know what? You're going to buy all your friends some chocolate. What does Agni need to buy some chocolate with? Money. Oh, yeah. I knew there was something. There you go. There's your £1. Sorted. I'm forgetting something. Oh, yeah, that's right. She's come to my shop, so she's got to give me the £1, hasn't she? Yeah. Okay. Oh, thanks, Agni. Brilliant. Great. Do you want something back?
Yes, please.
What do you want?
Chocolate.
Oh, chocolate, of course. So, I'll take the £1, and I'm going to give you in return 1. Pass them on. 2, 3, 4, 5, and 5 chocolate bars, and you've got some change as well. That's right. 20p. You can have that. Hold the change. I feel, ready? An equation coming on. Okay. 5 chocolate bars plus 20 pence is equal to £1, and you're saying each chocolate bar is 16 pence. How did you work that out?
I turned the £1 into 100 pennies, took away 20 from it, which is 80p. Then I divided it by 5, which is 16.
Superb. Let's just make this absolutely clear what's going on. Who's got the plus T-shirt? Oh, it's you again, isn't it? Okay, could you stand between Agni, okay, and Rangela? Okay? So we've got 5 chocolate bars plus 20 pence equals £1. The first thing we do is take away the 20 pence, isn't it? So, what we do to the
Left-hand side.
we must always do
To the right.
the same thing to the right. Okay, so let's take away 20p from both sides. Thank you very much. Okay, and we don't need the plus sign anymore, do we? Give them a little ripple if you want. Yeah. So, I had a £1 coin, so I need to take 20p off that to get... What have I got now? 80p. Is that 80p?
Yeah.
Is that 80p, Rena?
Yes.
Will you do me a favour and hold it for me and come up to the front? Okay, so Rena's now got me 80 pence. So I want to see what I'm doing here. Yep, 5 chocolate bars equals 80 pence. Right, how can we turn these 5 chocolate bars here into 1 chocolate bar?
We divide it by 5, don't we?
Divide by 5. Excellent. So we'll divide this side by 5. So you, and you take your chocolate bars and sit down. Okay. We're left with 1 chocolate bar on the left-hand side of the equation. And what must we do to the right-hand side?
Divide by 5.
Divide by 5. 80 divided by 5.
16.
So take your 10, your 5, and your 1. Of course, we've got 1 chocolate bar, which is equal to 16. Give me the money and sit back down. Thank you very much. You can take your chocolate. Okay, now then. You know that I also sell fruits. Now look, I've got 1, 2, 3, 4 bags of apples, okay? Could you tell me how many apples are in all 4 bags? What's the total number of apples? Yeah?
4A.
4A. Brilliant. Okay. We've got the same number of apples in each bag, but some of the apples are good and some of the apples are bad. And I don't know how many are good or bad in each bag. I know what I'm going to do. I'm just going to put my apples in here. How many apples in each bag? A. Good. How many apples in total?
4.
Excellent. Right, let me see. Where are these bad apples? Aha! I found some. That's 1 bad apple. Is that 1, 2, 3, 4. Aha! I knew there was 1 hiding. 5 bad ones. Who can tell me an expression now for the number of good apples that are in this box that I'm leaning on? 4A.
4A minus 5.
Why 4A minus 5?
There are 5 bad apples.
Okay.
So then you took 5 apples out. So I took 5 apples away from the term.
Okay, from the 4A term, which was the total number of apples we decided were in all the bags, wasn't it? 4A minus 5. Excellent. Okay, 4. Where's that A? A, Vista, up you come. So you can stand here. Just stand here. A bit further along. Brilliant. 4. A. 5. Clint, up you come. 4A minus 5. Is that right? Yeah. Do you agree with me? Minus. Where's that minus gone? Brilliant. Minus sign. Give me a round of applause. Woo! We got there in the end. 4A minus 5. Phew. Now, let's have a look. Let's see how many good apples were in the box. Ben, could you help me? Let's bring the box out here. Ben? On your knees, Ben. Count them up.
19.
19 good apples. So, let's solve the equation. Shall we do that? What should we do to both sides?
You have to put plus on the other side.
Right, what will plus 5 do?
It will make 4A the subject.
What, you mean you just have 4A on the left-hand side?
Yeah.
Right, and you'd get rid of the minus 5?
Yeah.
So to get rid of a minus 5, we have to add 5. Okay, and what we do on the left-hand side? Okay, let's add 5. Goodbye. Goodbye. Okay, we need to add 5 to 19 to get... Hey, Yusuf, 24. Up you come. Could you sit down, please? Thanks. Yusuf. So we've got 4A equals 24. Okay, and what do we need to do both sides of the equation now?
Divide
Divide by 4 on both sides. Excellent. So you sit down, Esther. 24 divided by 4 equals 6. Up you come. Put your clipboard down. So, A equals 6. Group together, girls. Okay, A equals 6. The number of apples that were in each bag to start with was? 6. Yay, we've used the equations to solve the problem. Do you know what? We've done really well. I think you two can sit yourselves down. Give them a round of applause. Give yourselves a round of applause. And I think we should just relax.
There's a call for you. There's a call on the phone for you.
Probably my mum. Hello? But it wasn't my fault, boss. He says, you can't sell bad apples in your shop, so you've got to close it down. I was going to build a shop on the other side of the road as well, because what I had to one side, I always add to the other. Oh no, that's my plans ruined, but never mind, because I've got a new job. Yeah. Here we are in my park. I've always wanted to work in the fresh air. Do you like my gear? Yeah. Do you like my park? Yeah. What? It's quite small, that's the only problem. I want to make it much bigger. I want to make it into a nice big rectangular shape. The only thing is I'm really fussy. I want the length of my park to be 200 metres longer than the width. Okay. Should we call the width something?
W.
W for width. Yep. That's a good idea. Do you want to write W on the board? So we can call the width W. Okay, just write W. Where do you think? Go for it. That's spot on. Could we write the W on the other side? Yeah?
Do we have to?
Yeah, why not? Okay, so we could call the width W. What could we call the length? L. We could call the length L. Can you remember my fact?
The length has to be 200 meters more than the width.
Absolutely. Who can think of an expression with W in it based upon that fact?
L equals W plus 200.
Length equals W plus 200. So I think what? Do you know what? Instead of writing L, we'll write W plus 200. Excellent. Now then, I want to put a big fence right around the perimeter of my park, okay? What does perimeter mean?
It's the length around the shape.
All the way around the shape, the length all the way around. Good. So, can we write down on our pads an expression for the total length of fencing that I need? Okay, so what have we got here? 4W plus 400. Excellent. So that represents the length of fencing that would be required. Now, the only problem is I've only got enough money to buy a kilometre of fencing. Can we form an equation and solve it to find the width of my park? Okay, what have you got? Emil's written 4W plus 400 equals... Talk us through it, Emil. 1,000.
Well, 1,000 is 1 kilometre, and 4W plus 400, so it would be an exact kilometre around for his fencing, which how much he could afford. So that's the perimeter should equal how much fencing he can afford.
Excellent. So what you're saying there is that there's 1,000 metres in a kilometre.
Yep.
4W plus 400 equals 1,000. Very good. What's your line of working you've got, Agni?
I did 4W equals 1,000 take away 400,
Yep.
which equals 600.
Brilliant. 4W equals 600. And then to finish off...
Right, divide 600 by 4.
Okay, so we divide 600 by 4.
And that'll get us W.
Okay, so you do that then, Emil. So 1W equals 100 and... Okay, we've solved the problem almost. The width has got to be 150 metres. How long does it need to be? 350 metres. Why 350? Yep.
Because it's 200 metres longer than the width.
Absolutely. So 150 plus 200 is 350. Does that work? 350, 150. Let's add them up all the way round. What do we get? 1,000. Problem solved. I'm really looking forward to building this park, you know. What do I need in a park? What else do I need? Look at it. A playground. A playground. I was thinking of making 2 big play areas. The first play area I was thinking about, I want it to be triangular. This one I've got in mind, 2 of the sides, I want them to be 20 metres longer then the third. What sort of triangle would that be?
Isosceles.
Good. Do you know why it's isosceles?
Yeah, because two of the lengths are equal and the other one is not equal to the other two.
Absolutely brilliant. Okay. So, Melanie and Esther, could you just put your clipboards down? What I want us to do is make a plan of this triangle. Now, I want the base to be... So long. Thank you very much. I'm going to call the base of the triangle X. Okay? What does X stand for?
A variable.
A variable, so it could be any number. But we do know now, hopefully, we can come up with expressions for these two lengths. What have you got for those two, Ben? X plus 20 for each one. Right then, let's write down then an expression for the length of railings I will need for this triangular play area. You've got it. Brilliant. Can you tell me what you've got, Isabel?
3x plus 40.
3x plus 40. So we had the x's is 3 x's, and this 20 plus 20 is 40. Keep those two terms separate. 3x plus 40. Can we simplify that expression? No, we can't. Okay. Now, another play area. 2 more volunteers. Okay. This time, I want a square play area. So could you just set up a square play area somewhere over here? Yeah, nice big square. Oh, could you make it double that length of that line there, roughly? Brilliant, that's pretty good, actually. I like that. Okay. And finish that off. So just make it look roughly like a square coming down here, yeah? Brilliant. So how long did I say each length of this square was, guys?
Double X.
Double the base of the triangle.
2X.
2x. Now we've got a square play area. What's the length of each side of the square play area?
2x.
A 2x. So can we come up with an expression for the length, the total length of railings required for this play area? What did we get, Clint?
8x.
8x. Brilliant. 2 expressions, 2 play areas, and we want a set of railings around each play area. Did I tell you I want the same length of railings around each play area? I can feel an equation coming on. Woo! So we've got an expression for the railings required for the triangle. We've got an expression for the railings required for the square, and we know that they're equal.
I have.
Now then, would you like to write your equation on the board? You'd love to, wouldn't you? Okay. Right then, Sabina's equation is... What have we got? 3x plus 40 equals 8x. What do we need to do to both sides? Anyone got it? Yes?
Put the x's on one side and the normal numbers on one side.
Oh, I see. Right, I see. So what we're trying to do is get, if you like, rid of this 40, are we?
Get rid of the 3x and then put it to the other side.
We can get... Ah, we're getting rid of the 3x. Oh, I see. Right, so you mean if we take 3x away from this side, whatever we do to the left-hand side...
You must be to the right-hand side.
Good, brilliant. So take away 3x on the left-hand side, what's left? 40. Equals...
8.
40 equals...
8x minus 3x.
8x minus 3x. So 40, keep going. 40 equals...
5.
Good. So x equals... 8. We have a solution to this equation. What's the length of railings I need to buy to put around this square?
64.
Okay, why 64?
X equals 8.
X equals 8 and...
8 times 8 equals 64.
8 times 8 equals 64. So we need 64 metres round here. So do we need 64 round here? Yeah. Let's just check it works. If x equals 8... Okay. Is it working? 3 times
8
equals...
24.
24 plus 40?
64.
64. So this would end up being 8. How long would these two sides be?
28.
28. 28. Does it all add up to 64?
Yes.
Brilliant. I love that about maths because it all adds up. Hey! Hello again. Well, I want to plant some flowers. Now, I've got a bit of a problem actually because I want one of my flower beds to be a rectangular flower bed. The width has got to be 5 metres less than the length. And I want an area of soil of 66 square metres. So I want to know how long my flower bed needs to be and how wide it needs to be. I tell you what, I'll just move the flowers over here. We've got the flowers, we've got the flower bed, and how much area of soil have I got? I've got, can anyone remember? 66, thanks for reminding me. Okay, so, I'm going to let my length this time be X. Okay? The length's going to be X, so you might want to just jot that little diagram down onto your pads. The length has got to be 5 metres more than the width. What expression can I write down for the width? If the width is 5 less than the length, let's say Esther.
X minus 5.
X minus 5 is the width. Right then. Hey, I feel an equation coming on. But this is a more difficult equation. What you need to do now is think about what we've got. To get the area of a rectangle, we do length. Of course we do. So, X times...
X minus 5.
And that will equal... 66. Write that down. Okay. What have we got over there, Rena? Would you like to write that down on the board? What you wrote on your pad? I quite like what Rena's written. A lot of you have written something similar. Okay, if you just stand back, let everyone see. We've got X. What's this symbol, Rena?
Times.
Didn't we say goodbye to that a long time ago? Yeah, should we get rid of that? Doesn't matter. It's not wrong. It looks better. So X, open bracket, X minus 5 equals 66. Most of you have got that. Has anyone got the next line? Isabel?
X squared minus 5x equals to 66.
Brilliant. X squared minus 5x equals 66. Let's have a look what's on the right-hand side. We've got 66. And I want 0. What are we going to do to the 66?
Minus 6. Minus 6.
Minus the 66. What we do to one side...
We do to the
Absolutely. So take away 66 on both sides. See what you get. This is more like it. Whoa, yeah. That's looking good. We've got a nice quadratic equation. Okay. Mitchell, read out what you got.
X squared minus 5x minus 66 equals 0.
Okay, thank you very much. Okay, if you want to sit down, Rena, we'll just write this down more clearly then. So we've got x squared minus 5x minus 66 equals 0. Now then, to solve this equation, we need to find a value of x that make this equation work.
We need to factorize the equation.
Can you say that again?
We need to factorize the equation.
What do you mean by factorise, Yusuf?
Put it into brackets.
Now, do you know what? Okay, even though Yusuf can't put his name badge on the right way round, he's very, very good at maths because he's talking about factorising. Come with me, because I might need your help. This is getting a bit tricky. Okay? We need to factorise. Let's move this barrow out of the way for a minute. There you go. Right then, so up we go to the board. Factorise. So how many brackets? How many sets of brackets?
2.
2 sets. Go for it.
So
2 nice big sets of brackets. Oh, yeah, nice and big. Good. Right then. Okay, so we're going to factorise it. It's going to be a double bracket factorisation.
there's x on each.
Good. Can you use curly X? Because you know what I'm like with that straight X. It's all right. I'm a bit fussy. Okay, nice and curly. Nice and curly X. Okay. Curly X. Oh, I see. Because everything in this bracket, each of the 2 terms in this bracket, has to multiply each of the 2 terms in that. So one of the terms is going to be x times x, isn't it? Which is x squared. Right. Any ideas for the other numbers? Any ideas at all?
Something that times into minus 66 and something that adds up to get minus 5.
Brilliant. We need 2 numbers, exactly, Clint, 2 numbers that multiply to minus 66 and add to minus 5. What are those 2 numbers?
11 and 6.
Minus 11 and 6. Shall we just write it out more neatly? Minus 11 and 6. Do your nice X's again. Minus 11 and 6. Is he right?
Yeah.
Is Millimo right? Yeah. Minus 11. Write it down. I'm getting quite excited. This could be an answer. We could have found the answer. And plus 6. Let's just check that. So you're saying that, well, oh yeah, a minus times a plus is a minus. So minus 11 times 6 is minus 66, isn't it? Minus 66. Okay? And we've also got minus 11 times x, minus 11x, and then we've got plus 6x, which gives us minus 5x. It's going up from minus 11x, isn't it? Up to minus 5x. Brilliant. So we've solved the problem. How have we? Factorised it. Any other... We've got an answer? Go on.
We have to find the two solutions.
How do we do that?
By x.
Go for it. Curly x.
Yeah. X minus 11 equals 0. And x plus 6 equals 0.
So you're saying that either this number has to be 0 or that number has to be 0 to make the whole thing 0. Is that right? Because anything times by 0 is 0. All right. So now we've got two linear equations. Oh, they're sweet, aren't they? And then they're really easy to solve. So we've got two solutions for x. What are they? Write them down.
X equals 11.
Is he right? Yeah.
And x equals minus 6.
Is he right? Brilliant. Give him a round of applause. Well done. We've formed a quadratic equation and we've come up with two solutions. Now then, let's look at the flower beds. We've got x is 11 and x is minus 6. Here's the flower bed. Okay, here are the measurements. So x is 11, so the length is going to be 11? Yeah, I'm happy with that, 11 metres. And the width is going to be y6. Yes?
Because 11 minus 5 equals 6.
Of course it does. So 11 metres, 6 metres gives us an area of 66 metres squared. What about the other solution? X is minus 6. Does that work? Does x equals minus 6 work? Well, it's a solution to the equation. But can we have a length of minus 6?
No.
No. So we have to use the sensible solution to fit the problem of my flower bed. So there ends our journey through equations. We've looked at some linear equations, which always ended up with one solution. We also looked at some harder equations, some quadratic equations, which ended up with two solutions. Remember, when we've got equations, what we do to the left-hand side. Okay, make sure you enjoy your equations and get the right balance.